Okay, in this lesson we are going to work on solving equations that have some powers in them. Okay? Oops. All right, now besides solving the equations, you're going to notice that in the directions it also says leave your answer in simplified radical form, which means no decimals allowed. Okay, so we will get to that part here in a little bit. The first thing you want to know is that when you are solving the equations, you want to make sure that the parentheses with the power is all by itself. So on A, you will notice on the left side that the parentheses with the power is all by itself. There is no plus or minus number behind it, and there is no coefficient in front of it. So then what we want to do is we want to get rid of the power of 2. So we want to think what will help us eliminate a power of 2, or what will help us undo a power of 2. And you need to know that to get rid of a power of 2, you will use a square root. So I would take a square root of both sides. Now, why does a square root eliminate a power of 2? For the square root, they don't ever put the index number here, but remember the little index number is a 2. They don't put it there because they assume you know that because you call it a square root, so you must know the index number is 2. But since the index number and the power are the same, they just cancel each other out. So on this side, you are just left with x minus 3 equals. Now, another thing you have to remember that is if this equation has a power of 2, then that means that there must be 2 answers, because in a previous lesson we have talked about the highest exponent tells you how many answers you must have. So remember, if the exponent is 2, you must have 2 answers. So that will help you remember over here on this side, there's something special you have to write. Oh yeah, whenever I put a square root, I have to remember to have the symbols plus or minus. If that part doesn't also help you remember that you have to have plus or minus, another way you can remember that you have to have plus or minus is we have already covered the quadratic formula. And in the quadratic formula, you will notice that in front of the square root is the symbol plus or minus. So you should also remember it that way if you cannot remember that the power of 2 means you should have 2 answers. All right, now from here, we have the square root of 16. One of 2 things is going to happen. Either this is going to be a perfect square, or it's going to be a number that we have to do the factor tree for. So how are we going to know? Well, if you know your perfect squares, yay for you. If you don't know your perfect squares, then you're going to go to your calculator, which I have here, and you're going to test it. So you're going to do the square root of 16. If your answer is a whole number, no decimal, then that means it's a perfect square, which when I type in the square root of 16, I get 4. So that is a whole number, so that's a perfect square. If I would have got a decimal, then that means it's not a perfect square and I would have to do the factor tree. But if you already knew that and you knew the square root of 16 was 4, then you could skip the part on your calculator. So test it to see if it's a perfect square or if you have to do the factor tree. Okay, so then from here, I'm going to go ahead and solve this like a normal equation. So I'm going to add my 3 over. So I'm going to have x equals positive 3 plus or minus 4. And then these are considered like terms. I got a 3 and a 4, they're like terms, so I'm going to go ahead and split my plus or minus. So I'm going to have 3 plus 4 and 3 minus 4. So my first answer is 7, and my second answer is -1. And then those are my 2 answers. I am done. Okay, let's go to the next one. On the next one, I do notice that this problem has a -6 behind the parentheses. So the first thing I want to do is get rid of the -6. So I would start by adding that over. So then I get x plus 4 quantity squared equals 80. And then I can say, how do I get rid of a power of 2? I'm going to take the square root of both sides. And then I know that the square root and the power of 2 cancel each other out. Then I have to have plus or minus on the right side to ensure that I have 2 answers, because my exponent is 2. So now let's test 80. Let's see if that's a perfect square or not. So second square root 80. Oh, this one is a decimal, so this is not a perfect square. So that means I'm going to have to go back and I'm going to have to do a factor tree for 80. So over here, I'm just going to write 80 down and I'm going to do a factor tree. So any number you want that goes into 80, well, anything that ends in a 0 is always divisible by 10. So I'm going to go 10 and 8. 10, I'm going to do 5 and 2. 8, I'm going to do 2 and 4, and then 4 goes 2 and 2. So then I'm looking for 2 of the same number, and I have 2 2s, another 2 2s, and then I have a leftover 5. And remember, you are not allowed to use 10, 8, or 4 because those numbers broke down. So I get to put 1, 2 for the first pair on the outside of the root. I get to put another 2 on the outside. And I'm going to multiply those together. And then inside the root, I get to put my leftover number, which is a 5. So I would have 4 square root of 5. So now I just want to get x by itself. So I'm just going to move my 4 over. And when I move my 4 over, I have to subtract it. So x equals -4 plus or minus 4 square root of 5. Now, are these two considered to be like terms? And the answer is no, because one of them has a square root attached to it and the other one does not. So they are not like terms. So please do not say, I'm going to split the plus or minus and get 2 separate answers. No, 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 no. You can leave your answer like this, or if you want to write your answer, you could write it like this, but you can't actually combine the -4 and the +4. Okay, but if you wanted to separate the plus or minus, you could like this, but please do not combine the -4 and the +4 because the one has a square root of 5 attached to it and the other one does not. So I don't care which way you write your answer, but remember with the plus or minus, that means it counts as 2 answers, or if you like to split it to see the 2 answers, then there you go. Okay, next one. Still start with the plus or minus number behind it, even though it has a coefficient. Okay, so start with subtracting 5. So then you have 2 parentheses 2x plus 7 quantity squared equals negative 240. And then you want to get rid of the coefficient in front. Okay, you are not allowed to distribute the 2. This parentheses has a power, so if your parentheses has a power, you are not allowed to distribute a coefficient into it. So if I cannot distribute into it, then that means I want to divide the coefficient away. So then I'm going to divide the 2 away. So then I have parentheses 2x plus 7 quantity squared equals negative 120. And then to get rid of the power of 2, I am going to square root it. And then on the front side, the power of 2 and the square root are going to cancel out. So 2x plus 7 equals plus or minus. Uh-oh, I see a negative under the root. And if I see a negative under the root, that means I have to put something special on the outside. And hopefully everybody says, oh, I remember. That means I have to put an I on the outside. So when you go to test if this is a perfect square or not, please do not type the negative in on your calculator, because if you type in your negative under the calculator, it'll say error. Please don't do that. Just remember that means you're going to put an I out there. So if I type in 120, it's going to give me a decimal. So that means it's not a perfect square. So I'm going to have to do the factor tree. So I'm just going to kind of scroll down here. I'm going to squeeze it in over here on this side. So 120. Once again, I'm going to do 10 and 12. I'm going to do 5 and 2, 2 and 6, and 2 and 3. So I'm looking for a group of 2, which I have a pair of 2s. Then I have a leftover 5, leftover 2, leftover 3. Do not use 10, 12, or 6 because they broke down. I get to put 1 2 on the outside, and then on the inside I get to put a 5, a 2, and a 3. So on the inside, make sure you multiply those numbers together. So I would have a 2, and then because it was a negative, make sure you put an I outside of the root, and then inside I'm going to multiply those for 30. So up here, I will have plus or minus 2i square root of 30. So now I'm going to work on solving. So I'm going to move my 7 over. And when I move my 7 over, it becomes a negative. And then I have to get rid of the coefficient in front of my x. And in order to get rid of that, I'm going to divide it away. So negative 7 plus or minus 2i square root of 30 all over 2. And then the last thing I want to do is see if it reduces. So if I look at reducing, does anything go into 7, 2i, or 2? And the answer is no. So then this would be my final answer. Okay, but let's do the what if game. What if, what if, what if? I love to play the what if game. So what if this was my answer? What if I had negative 6 plus or minus 2i square root of 30 all over 2? Okay, then remember you're looking at our, I don't know if you want to call it like a nacho, but you're looking at this triangle right here. Some people want to call it like a slice of pizza. I don't know. But don't touch the square root of 30, but you're looking at these outside numbers here, and all of these outside numbers, you would say, ooh, they are divisible by 2. So then if I divide them by 2, I would have -3 plus or minus 1i square root of 30 all over 1, which you wouldn't really have to write all over 1, but that would make your final answer if we played the what if game. Okay, but remember, don't ever reduce the number inside the root. Thanks.